Okay, so I hope at this point you feel comfortable turning a regular expression into an NFA. If you don't, you should go back and practice that some more because we're about to go into somewhat harder territory. It's really not too bad, but it's a bit more complicated. At some level, we're just kind of going backwards from where we were before, so that we'll start with an NFA or a DFA, and then in the end we're going to end up with a picture that looks kind of like this, with a start and an S and a double circle F, and we'll have some expression here which will represent the regular expression that our NFA actually represents. So remember, we're starting with a DFA or an NFA, and we're going into a regular expression. So this slide tells you what the setup steps are, because again, there's a setup phase and then a phase where we slowly get rid of all of the states that are in the DFA or NFA until we just have this start and final state. But actually for this one, it's much easier to show you it once and then talk you through it again than to really go through all of this step by step. So I'm going to gloss over the slide for now and say here's the rules. These are straight out of your book, but you can look on the copies of the slides you get too. And you know, I occasionally add something here, but we'll go through this in an example in a minute. So this slide is really grabbed from the book of how to get rid of one of the states in your NFA, and we're going to keep getting rid of states in your NFA one after another until we end up with that single start and final state. But again, we're going to ignore this slide for now. I put it in here so you can see the rules if you want to see the rules, and this will make sense after you finish watching these slides. But for now, if you don't worry about trying to understand what is actually written on this slide too closely. Just believe this is the how to get rid of all the different states one at a time. And then the procedure finishes with one last step, which I call the wrap-up step, which basically says you now end up with just two states, S and F, and if there's an edge between S to F, then that regular expression tells you your answer. So we're going to start with an example from the textbook on page 714. And what I'm going to do is I'm going to go step by step through this procedure and show you what's going on. But I'm going to give you a little bit more detail than the book does, just so you can see what's going on. So the first step of the setup is to create a new start state S and draw a new edge labeled with a lambda from S to the original start state. So up here in the top right corner is what our NFA started to look like. Actually, this looks like a DFA to me, right? Every single state has an out transition for every letter of the alphabet, so it's both a DFA and an NFA. But anyway, so let's create a new start state. So here's my new start state S. And we're going to have a new edge labeled lambda that goes from S to our original start state. So this is our original graph. And after we do part one of the setup, we have this graph. Part two of the setup is to set up a new final state. So we make a new final state that has a double circle. And any state in our DFA or NFA, I guess it has to be, we have to call it an NFA now because we have this lambda transition, but any state that's in this machine that has a double circle, we put an arrow to the F with lambda on it. So if we actually had a double circle on 2 in our original machine, then we would have put a transition from 2 to F as well that has a lambda on it. And while the book doesn't say this explicitly, I find it easier if you just get rid of all of the old double circles, because now everybody who has a double circle points to this new double circle with a lambda transition. Okay, so now we have the last of the setup steps. And what it says is, for any pair of states that have more than one edge from I to J. So if there's anything that has more than one transition from I to J, replace all the edges from I to J with a single edge labeled with the regular expression formed by the sum of the labels on each of the edges from I to J. So let's talk about what they're saying here. So let me just move that out of the way for a minute, and then we'll see how I did it in this particular example. So what they're talking about is the following. Suppose that you have a graph, and somewhere in the graph you've got a couple of states. We'll call this state 1 and this state 43. And between state 1 and 43, maybe you have A, and you have B, and you have D. And of course, another way that we sometimes write that in shorthand would just be you have from 1 to 43, you have A, comma, B, comma, D. But regardless of how you look at this, what this rule here is saying is you have the 3 transitions that go from state 1 to 43. And in this case, remember this A, comma, B, comma, D on one arrow is shorthand for this picture down here. And all this is saying is if you have something like this or something like this, you're going to change it into something that is not a DFA, right, but is still kind of understandable. So you'll say you'll have 1 to 43, and you're just going to write up here A plus B plus D. Okay? So that's all you're going to do is turn any commas that you have on a single transition or multiple transitions that go from one state to another state. If all of them go to the same next state, you're going to turn it into the sum of some regular expressions. So going back to this guy, this slide, here's what our machine looked like before. And what we're going to do is anywhere where there are 2 edges that go between the same states, we're going to make it the sum of edges. And in here, if you look, the places where there's 2 edges, well, this A comma B loop here actually represents 2 transitions, one from 2 to 2 that takes A and one from 2 to 2 that takes B. And so we turn that into A plus B down here. And then we have the same thing up here on this transition from 1 to 1, so we turn it into A plus B over there. Okay, so great. So that's the setup, and we're now done the setup stage. Now, the next thing that you need to do is you start eliminating the states until the only states that are left are your start state and your final state. And in order to do this, you need to understand some terminology. So we're going to use the terminology old IJ to mean the edge between I and J, the transition between I and J on the current machine. And remember, since we did that last setup step, there's only ever at most one edge between any 2 nodes. So for example, if we say what's the old edge between 0 and 2? Well, the old edge between 0 and 2 is B. And what's the old edge between 0 and 1? The old edge between 0 and 1 is A. Remember, old just means what we have right now. The old edge from 1 to 1, that's A plus B. The old edge from 1 to 2, oh, well, there's nothing from 1 to 2, so we're going to call that the empty set. And now I just want to pause for 1 second and give you some terminology that is my personal terminology that the book doesn't use, but I think makes it easier. So I'm going to say that a node is en route between 2 other nodes, and we're going to call the node that's en route between K. And K is en route between 2 other nodes if K is different from the other nodes and there is a path from the other nodes through K. So formally, here's how we say it. I isn't the same as K. J is not the same as K. The old transition from I to K isn't the empty set. In other words, there is some transition from I to K. There's some old transition from K to J. And the important thing to notice is it's okay if I and j match up. So what you want to think about is, for example, here, if I have something like this in my machine, this is a path that takes me from 1 via 2 to 3. So you can think of that as between 3 cities, for example. So we could say, all right, well, I start in Philadelphia and I go via Trenton and I end up in New York City. But we'll say that state 2 is en route between 1 and 3. To get from 1 to 3, we can go via 2. Similarly, down here, the one that's en route between can be in between the same state and itself. So for example, here I say 5 is en route between 4 and 4 because you could start at 4, go via 5, and end up at 4. So you could, of course, start in Los Angeles, travel to San Francisco, and then end up back to Los Angeles, and it would be a very strange trip to take, but San Francisco, in this particular case, would be on the route between Los Angeles and Los Angeles. In this graph, it's interesting because also it looks like 4 is en route between 5 and 5, right? Because we can start at 5, go via 4, and end up at 5 again. So since this isn't in the book, just to make sure you understand my en route between, if we just consider who is 2 en route between, well, 2 is en route between 1 and 3, right? Because we can go from 1 to 3 via 2. 2 is also en route between 1 and 1, right? Start at 1, go via 2, end up at 1. It's also between 4 and 1, so we start at 4, go via 2 to get to 1, and it's also between 4 and 3. Start at 4, go via 2 to get to 3. 3 in this picture is not en route between anyone. 4 is not en route between anyone because there's no way to get to somebody going via 3 and no way to get to somebody going via 4. So here's where we were at. If you remember, we had just done the setup, and so we had ended up with this nice machine, and we weren't sure what to do next. Now we had to do this, eliminate the nodes. So we're going to have to eliminate 0, 1, and 2 somehow, and then we will get our answer. The book doesn't say this, but you can get rid of any node that's not en route between anything. So if you look at node 2 in this picture, node 2 in this picture is not en route between anyone. And if it's not en route between anything, that means there's no way we're going to go via 2 to get anywhere, and in particular we're not going to go via 2 to get to the final state. And if we're not going to go via 2 to get to the final state, we can just get rid of that node and any of the transitions that lead into that node or out of that node. Okay, so the next step is to get rid of any nodes that aren't en route between anyone, and then we're going to get rid of the eliminate state K step. And here's the rules, so let's just go through it quickly and then I'll show you how it works. It says call the node that you want to get rid of K. So since I said let's start with state 0, because you can do this in any order you want. You can pick whichever node you want to get rid of first, and I've decided I want to get rid of state 0. So call the node you want to get rid of K. So let's just label that one K. So there's going to be K is going to be state 0. And it says for every pair of edges IK and KJ, where I doesn't equal K, J doesn't equal K. In other words, my terminology, every pair that K is en route between. So if we look at my K for a minute, K is en route between, or state 0 is en route between S and 1. So we're going to call SI, and 1 will be J. Okay, so these are just names for these nodes. What we're going to do is we're going to make a new transition between whoever is the I node and whoever is the J node, right? So in this case, what we're going to end up doing is we're going to end up making an arrow between S and 1, and we're going to figure stuff out so that however you used to go via 0 to get from S to 1, we'll still be able to get that along this transition. So in this case, if you look, when you take the path from S to 0 to 1, you end up with a lambda followed by an A. So what we're going to want to see in the end written on this transition is an A, because if we end up with an A on that, then we could actually get rid of all this stuff. Okay? And the way that we compute this, the equation that's going to give us that A, is right here. And we just have to plug in the numbers. So it says the new ij equals the old ij, blah, 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 blah. You'll see this will make sense in a minute. But for now, let's just go to the next slide and we'll try it. So remember, I've decided to eliminate state 0 because I felt like eliminating state 0 first. And here's my rule. It says for every pair of edges, da, 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 so you can read that for a minute. And we decided that state 0 was going to be my K, and state S is going to be my I, and state 1 is my J. And this says the new I to J is the old I to J plus the old I to K concatenated with the old K to K starred concatenated with the old K to J. So in this case, since I is S and J is 1, the new path from S to 1, right, that's the same as the new IJ, is the new path from S to 1, equals, and now what I'm doing is I'm just translating. Old IJ, that means old S1. Old IK, old S0, and so on. Old KK is the old 00, old KJ is the old 01, right? And so I know that my new path from S to 1, remember I'm trying to make a new transition from S to 1 so I can get rid of that 0 state, is going to actually equal this stuff. So let's plug in the old S to 1. Well, the old S to 1, there didn't used to be anything between S and 1, right? So the old S to 1 was the empty set. The old S to 0 was a lambda, so you can see here I translated this old S to 0 as a lambda. The old 0 to 0, well, there is no loop from 0 to 0, so that's the empty set, but we have to star it, so that'll be the empty set starred. And the old path from 0 to 1 had an A on it, so we copied that down. And now what I'm going to do is I'm going to say, all right, well, so we have the empty set plus lambda times the empty set starred times A. And now, just to show you that that actually works out as A, I decided to follow the rules on page 700 and simplify this. You do not have to simplify in these things, but you know, if you have a bunch of lambdas and empty sets, it's nice to simplify it. It does make it easier for you to understand. So remember that if you have lambda times anything, it's just the thing. So instead of having the empty set plus this stuff, we have the empty stuff plus the empty set plus the stuff without lambda on it. If you take the empty set and star it, that means 0 or more occurrences of nothing, right? Well, 0 occurrences of nothing gives you lambda, but any more than that doesn't give you anything else. So it turns out that lambda star by property 2b, you can look it up if you want. I'm sorry, the empty set starred by property 2b is lambda. So we've simplified the equation to this, and back to lambda times anything is just itself, so we end up with the empty set plus A. And remember that the empty set is, right, the set with nothing in it, and plus represents union, so we're really saying take the union of the empty set and A, which equals just the set containing A, right? So, and you know, if you look at the properties or the rules on page 700, you'll see that's actually rule 1b right here. Okay? So we end up with saying the new S1, what you should label your new S1 is A. So we can put an A on here, and we can scribble all that stuff out. And here's what we had before we started. And after drawing that arrow and writing an A on it and scribbling all this stuff out, we end up with this pretty picture at the bottom, right? Okay, so I'm just going to decide that the next state I'm going to get rid of is state 1. So I want to get rid of this state, and I say, who is state 1 en route between? Well, state 1 is en route between S and F. So since state 1 is en route between S and F, I'm going to say, all right, well, state 1 is my K, S is going to be my I, and F is going to be my J. So when I try to compute this new IJ, that's actually computing the new SF, right? We're trying to compute what's that new arrow going to be from S to F. And if you just look here at my equations, I take the original, translate it. The old start to finish, well, there didn't used to be any transitions from start to finish, so that was the empty set. The old transition from S to 1 is A, because that's what we just set up. The old transition from 1 to 1, oh, well, now there is one there. That's A plus B, and we have to star that. And the old transition from 1 to F was a lambda, so we put that there. And we multiply it through, we simplify it, and we get A times A plus B starred. And so that what that means is that the new connection between S and F is going to be labeled as A times A plus B starred. And we're going to get rid of all this stuff in here. And if you look down here at the bottom, that's exactly what we have, right? We have our start state, and there's only one transition to our final state, which says A times A plus B star on it. And so now we look at this and we say, we've gotten rid of all of our states. All that's left is S, our start state, F, our final state, so we have our regular expression. So here's another example from the book. This says use the algorithm to turn this NFA into a regular expression. I'm just looking at it. Is it also a DFA? No, it's not a DFA, right? Because if I look, state 2 has a B going to state 3, and it also has a B going to state 1. So this is an NFA, and we want to turn it into a regular expression. So we're going to use that algorithm to do it. Okay, so let's just move this out of the way so we have a little bit of room to work. So let's go for it. Let's do the setup. So the setup involves, there's our start, and we have a new state S, which has a lambda transition to state 0. 0 has our A transition to state 1, which has a B loop. It has a transition with A on it to state 2. It has an A loop, and then there's also a B loop going back here. There is a B loop to state 3, which used to be a final state, but I'm going to just do step 2 of our setup right here, and I'll have a lambda transition from there to double circled F. Okay, so that is the setup almost done. We need to look for that last part of the setup where we say, are there any transitions that have 2 regular expressions on them that we want to take the sum of instead? But we look at this and we say, no, everybody's just a single symbol. Okay, so let's take this and shrink it down a bit. And it said that we had to eliminate state 2 first. So let's do that. So we want to get rid of state 2. So let's take a look at state 2 for a second. I'm going to change colors so that every time we do something, we change colors. So state 2, I want to get rid of state 2. So who is state 2 en route between? And when I look at this, I see that state 2 is en route between a couple of different people. There's a path from 1 to 3 that goes via 2. And then there's also a path from 1 to 1, right, that goes via 2. And I think that's it. But so what this tells me is I'm going to have to run this equation twice. I'm going to have to figure out what is the new transition from 1 to 3. And I'm also going to have to figure out what's the new transition from 1 to 1. Because really, if you look at this, when I get rid of 2, I need to have a new way to get from 1 to 3, and I need to have a new way to get from 1 to 1. Okay, so we need to figure out both of these things. Okay, so let's just write that down here in the corner so we'll remember it. We're going to have to figure out the new 1 to 3 and also the new 1 to 1. And it doesn't really matter what order we figure them out in, we just need to figure out both of them. Okay, so I'll stick that up there. All right, so we need to figure out the new 1, 1. Well, if you look at the equation, the new 1, 1 if we're going via 2, is the same as the old 1, 1 plus the old 1, 2 times the old 2, 2. Okay, maybe that's a bit big, so let's see. Let's shrink it a little bit so I can fit stuff in here. So we have times the old 2, 2, which we need to star, times the old 2, 1. Okay, so let's figure out what all these pieces are. The old 1, 1 from 1 to 1 is a B. Maybe we should make this a little bit bigger so we can look at it for now. Right? So the old 1 to 1 is a B. So we'll copy that down here. The old 1 to 2 is an A. The old 2 to 2 is also an A. And we have to star that. And the old 2 to 1, which is right here, is a B. You can't quite see it, but it's a B. All right. So we have that the new 1, 1 is going to be equal to B plus A star B. Okay. So that was our computation for the new 1, 1. Now we got to figure out the new 1, 3, because remember, to get rid of state 2, which is what we're trying to do, we need to get rid of anybody, we need to figure out new paths for anybody who goes via 2. So we'll figure it out for the new 1, 3 now. So let's take this and shrink it down. And so now we're trying to figure out the new 1, 3. So the new path from 1 to 3 is going to be the old path from 1 to 3 plus the old 1 to 2 times the old 2, 2 star times the old 2 to 3. And so we look and let's see, the old 1 to 3, oh, well, there is no 1 to 3, right? So the old 1 to 3 is the empty set. If I look, the old 1 to 2 is an A. The old 2 to 2, well, sure enough, there's a loop there. So that gives me A star. and the old 2 to 3, can you see that? That's actually a 2 here. The old 2 to 3 is just this B. And of course, taking the union of the empty set with anything else just gives us that anything else. And so we figured out that the new 1 to 3 is the same as A star, B. Cool. Okay, so let's just get rid of all this stuff. There we go, now we have some room to work. So what we need to do is we need to take this picture that we had here, and we need to redraw it, except we're going to redraw it without state 2 and with these new transitions. So let's start by drawing it. We have our start goes to an S, which has a lambda to state 0, which has an A to state 1. State 1 has a loop with a B on it. We're not going to draw state 2, but we will draw state 3, and state 3 has a lambda transition to the double circled F. And then let's see, we need a new state from 1 to 1. Oh dear, you know what? It's no longer just B anymore, it's now B plus AA star B, so let's change that. And the new state from 1 to 3, sorry, the new transition from 1 to 3 is just a plain old A star B. Okay? So that's state 2 eliminated. Of course, now we need to eliminate state 1 and state 0 and 3, and the book didn't tell us what order to do those in, so we can pick whatever we want. Let's look at eliminating state 1 for a minute. When we want to eliminate state 1 now, we need to say who is state 1 en route between. And it looks to me like state 1 is only en route between 0 and 3. I don't see any other paths through 1 at this point. So that's not too bad. So we need to figure out, let's change to purple, we need to figure out a new path from 0 to 3. And of course, remember, I decided to eliminate state 1 because I feel like eliminating state 1 now. I could have picked any other one. The problem said do state 2 and then state 1, so let's do that. So the new 0 to 3 is the same as the old 0 to 3. And I'm just doing this based on that equation plus the old 0 to 1, and again that's too big, so let's shrink that. So new 0 to 3 equals the old 0 to 3 plus the old 0 to 1 times the old 1 to 1 starred times the old 1 to 3. So what do we end up with here? Let's see. The old 0 to 3, well, there is no transition from 0 to 3, right? So I can skip that. That's just the empty set. The old 0 to 1 is an A. The old 1 to 1 is a mess. That's a B plus A star B. And now we have to star that whole thing. And the old 1 to 3 is just A star B. So our final equation is the new transition we need to make between 0 and 3 is going to equal A times B plus A star B, the whole thing starred, times A star B. Okay. Okay, so let's see, let's shrink this one a bit so we have some room to draw our next step. Maybe we'll put that there. And take all this stuff and we'll put it down there. We're going to get rid of that in a minute. So we're getting rid of state 1, so we need to have our start state, and we have as lambda transition to state 0. And we're getting rid of state 1, so we're going to leave it blank for a minute there. And here's our 3, and 3 has a lambda transition to F. And so our new transition from 0 to 3 is all this stuff down here. So it is A times B plus A star B, whole thing starred, times A star B. And let's make that look a bit better. And now we're ready to do our next step, which is either eliminate state 0 or eliminate state 3. Why don't we eliminate state 0 next? Alright, so let me clean this up a little bit just so we have some more space. Alright, and so now we need to pick another state to eliminate. We could eliminate state 0 or we could eliminate state 3. Why don't we eliminate state 0 first? So let's see, who goes via 0? Looks like the only people to go via 0 are S goes via 0 to 3. So we need to figure out a new transition from S to 3, which is the same as the old transition from S to 3. Plus the old transition, oops, that should say the old transition from S to 3, plus the old transition from S to 0 times the old transition from 0 to 0 starred times the old transition from 0 to 3. And life's getting simpler now because there is no old S to 3, so that's the empty set. And the old S to 0 is just a lambda. The old 0 to 0 is the empty set, so we star that. And the old 0 to 3 is this big mess here. So I'm just going to write mess. And of course our lambda star, or sorry, our empty set star is the same as lambda, so we just end up with our mess. So really all we need to do is to eliminate state 0 is we copy that stuff in as the transition from S to 3, which is kind of what we figured. Alright, so let's clean this up a bit. So if we shrink that down a bit here, what we did was we said we now have our start with a big circle around it, and we'll have our big transition to 3, and then there will be a lambda to our F state, and between S and 3 we will have A times B plus A star B all starred times A star B. And we are almost there. The next step, of course, is we need to eliminate state 3. And what you will find when you eliminate state 3 is that you get exactly the same thing again. I'm not going to do it, but if we eliminate state 3, then you end up with something that looks something like this. You have your start state, you have an S, big long line to your double circled F, which has the same equation on it. And if you just go through the example, you'll see it works. And phew, we did it. We made it from our original NFA all the way to this mess, but that mess there, that mess is the answer to our problem. That is the regular expression that represents this crazy NFA. Now what you'll find is if you eliminate states in different orders, you'll end up with different regular expressions, and those regular expressions are equivalent, but they may not look exactly the same. Now let's just sanity check this for a minute. Let me clean up the area. And so we've got this as our final regular expression, which is A times B plus A star B starred times A star B, right? And theoretically, this regular expression represents that NFA way up at the top. So let's take a look and see if it does. Let me do a little bit more cleanup. There, that feels better. And let's bring this down and stretch it out a bit and take a look. So what does this tell us? This says that for this NFA up here at the top, you have to start with an A no matter what. And I agree with that. You have to start with an A. And then you have this choice. As many times as you want, that's what this star means, right? You can either take a B by itself, or you could take an A star B. And you can, the first time take a B, the next A star B, the next B, the next B, the next B, the next A star B. So let's see. The B by itself makes sense. This is basically instructions on how to start at state 1 and end back at state 1. So you can start at state 1 and end back at state 1 by taking as many B's as you want. And you can also go from 1 to 1 by taking an A, as many A's as you want, and then a B, and you're back at 1 again. So everything in this piece of the equation here is really saying, here's how you can start and end at state 1. So this first A is kind of starting at 0 and going to 1. This second big piece is how you can start and end at 1, right? You can keep ending up back at 1. And then once you're at 1, if you want to go from 1 to 3, you need to take an A, then as many more A's as you want, and then a B. And that's what this says right here. So believe it or not, all that mess, we really did turn this NFA into a regular expression, which is really pretty cool. Okay, let's do one last example of this. And so let's move that out of the way a little bit so we can do our setup phase. And remember, our setup says you start with a new start. And we have our S state, which goes to our old start state, which was 0. And then we have an A transition going to state 1. I'm going to undouble circle that one and do the second setup state, which says send that, oops, there was a lambda transition over there, and send that with a lambda transition to our double circled final state. From state 0, if you look, we could also go via a B down to state 2, and state 2 has an A loop on it. And if you look over here, state 2 is also an accept state, a final state. So state 2 is also going to point to that double circle F. Okay? So we're going to have to eliminate states 0, 1, and 2 to do this. And by the way, if you look, I don't see any states that have 2 arrows that are the same, that are between 2 states, and so we don't need to do that last part of the setup. So now we get to pick who we eliminate first. Let's shrink our new picture down to a more manageable size. Let's put it right there. And why don't we get rid of state, I don't know, why don't we start with state 1 first, okay? So state 1 looks to me like state 1 is only en route from 0 to F. So we need to figure out a new path from 0 to F. And the equation for that is the new 0 to F is the old 0 to F plus the old 0 to 1 times the old 1 to 1 starred times the old 1 to F. Oops, that's supposed to be an F. Alright, and the old 0 to F, well, there is no path. Transition from 0 to F, so that's just the empty set. And the old 0 to 1 is an A. The old 1 to 1 is a B, but we have to star it. And the old 1 to F is a lambda. So when we simplify this, we just get A, B star. So what we're going to do is take that A, B star, and that's going to be the new path between 0 and F. Okay. So, I mean, really what we're going to end up doing, right, is we're going to get rid of state 1 and all those stuff that went from 0 to F. We're going to make a new transition there from 0 to F, which is going to have this A, B star on it. Okay? So let's do that a little bit more neatly. We're going to put A, B star on a transition from 0 to F. And there you go. So let's just shrink this one a little bit. Let's shrink our new one a little bit. And why don't we get rid of state 2 now? So it looks to me like state 2 is only en route between 0 and F. So that means that the new 0 to F is going to be the same as the old 0 to F plus the old 0 to 2, and we're running out of space. Let me just shrink that a bit. Oops, I lost this piece. Here we go. So we have the new 0 to F is the old 0 to F plus the old 0 to 2 times the old 2 to 2 starred times the old 2 to F. Now, if you do a few of these, you'll get into the routine of this, and it actually kind of makes sense. Look, what are we saying? In order to make a new path from 0 to F, we need to take into account any old way we got from 0 to F, and then any old route that went through via state 2. So that's kind of what's going on here. So the old 0 to F is, that actually exists now, that's A, B star. The old 0 to 2 was B. The old 2 to 2 was A, which we have to star. And the old 2 to F, my goodness, I didn't draw that in there. Somehow it got lost. But that was that lambda, so we will just say that is lambda. And so when we simplify this, we get A, B star plus B, A star. Okay, so let me just make a note of that. We're going to be putting in the new 0 to F is going to be AB star plus BA star. Now I can clean up a bit. Okay, so we eliminated 2. So we now have our start, which has an S, and we have a lambda transition to a state 0, and the transition from 0 to F is going to be this A, B star plus B, A star. And now we are almost there. Let's shrink these and move them over. So we just need to get rid of state 0, right? And that is pretty straightforward because 0 only goes from S to F. And as you're going to guess, we're just going to get rid of that lambda, but we'll look at it anyway. So the new SF is the old SF plus the old S to 0 concatenated with the old 0, 0 star times the old 0 to F. And let's see, the old S to F, well, there was no connector between S and F, so that's the empty set. Old S to 0 was lambda. No 0 to 0, so we're just going to make that the empty set starred. And the old 0 to F was A, B star plus B, A star. So remember, the empty set starred is just lambda. So what we end up with is the new S to F is going to be A, B star plus B, A star. Let me clean up again. So we will have start, and we will have S to F, and on there it will say AB star plus BA star. And since there is nothing else, no other states on here besides S and F, we know that we've got our answer. Okay, so let's take a look at that and compare it with where we started. So what we discovered was that this NFA is represented by this regular expression. And if you look at it, it says it's all the strings that start with an A and then have a bunch of B's, 0 or more B's, unioned with all the strings that have a B and then a bunch of A's. And sure enough, look, there's an A and a bunch of B's, and there's the other path that has a B and a bunch of A's. So it worked again. And if you made it to the end of this slide set, good job. This was long, but it's good stuff. The only thing I'll add here at the end is this really is something you just need to do. If you do it a few times, you'll totally be set. You'll be able to do it, but you really need to do it on your own a few times to just get in the rhythm of things.